Hello, I am Professor Maria LBS Salingay. I will be teaching you today the basic of measurements. The preferred unit of measurement is the SI units, from the French word centime international de unités. It has 7 base units from which all other units are derived. For physical quantity length, it has an SI unit of meter, or abbreviated as M. For mass, it is kilogram, abbreviated as small kg. Temperature, the SI unit is Kelvin, abbreviated as capital K. Time, SI unit is second, abbreviated as S or SEC. Amount of substance, SI unit is mole, or abbreviated as mol. For physical quantity electric current, the SI unit is ampere, or abbreviated as capital A or AMP. And luminous intensity, with an SI unit of candela, or abbreviated as CD. SI base units are used to formulate derived units obtained by multiplying or dividing one or more of the base units. Speed, for example, has a unit mass per second. Volume has a unit of meter cube or liter, wherein 1 liter is equal to 1000 ml, or also equal to 1000 cm cube or centimeter cube, as 1 ml is also equal to 1 cm cube. Prefixes are used to indicate decimal fraction. Prefix, for example, peta is abbreviated as P, meaning it is 10 to the power of 15. Prefix tera, or capital T, is 10 to the power of 12. Kilo, small k, is 10 to the power of 3. DC, small d, is 10 to the power of negative 1. Milli is small m, 10 to the power of negative 3. Micro, or mu, is 10 to the power of negative 6. Nano, or small n, is 10 to the power of negative 9. Now, let's go to significant figures and uncertainty in measurements. First, let us review and be familiarized with the rules of significant figures. First, all non-zero digits are significant. For value 234 kilograms, it has 3 significant figures. For 12.59 meters, it has 4 significant figures. And for value 2.4567 grams, it has 5 significant figures. For the second rule, zeros between non-zero are significant. For value 1155 cm, it has 6 significant figures. 50.08 kilograms, it has 4 significant figures. And 30,015 grams, it has 5 significant figures. For the third rule, zeros at the end of a number are significant. For value 5.00 grams, it has 3 significant figures. For value 0.5400 liter, it has 4 significant figures. And 0.2345 gram, it has 4 significant figures. Now for the fourth rule, zeros at the beginning of a number is not significant because the zero here is only used to denote that such value is less than 1. For value 0.4500 gram, it has 4 significant figures. And 0.950 liter, it has 3 significant figures. Now for the fifth rule, zeros in money are significant. For value like 1,000 pesos, it has 6 significant figures. In reporting measurements, you have to consider uncertainty in measurements. So in measuring mass, for example, you have 4 significant figures like right after the decimal place. You have to consider uncertainty in measurement. So when you report mass, for example, 2.4568 gram plus minus 0.0001. In volume also, if the significant figures is two decimal places right after the decimal point, you have to report volume measurement as 49.98 ml plus minus 0.01. Now let's go to scientific notation. Sn is used for extremely large or small numbers expressed in capital N times 10 to the power of small n, where capital N is any number equal to or greater than 1 but less than 10, and small n is an exponent. So meaning in Sn, there is only one whole number at the left of the decimal point. So for large value like 560 million, the Sn considering Sf is 5.6 times 10 to the power of 8. Why to the power of 8? Because you need to express it in such a way that you only have one whole number at the left of the decimal point. So where is the decimal point in 560 million? It is at the last zero. The last zero, you move to the left, you move 8 times to make one whole number. So that's why it's 5.6 times 10 to the power of 8. For small values like 0.000003, we have 5 zeros at the right of the decimal point. So to write it in scientific notation, it is 3 times 10 to the power of negative 6. You may ask, why negative 6 when there's only 5 zeros after the decimal point? It becomes negative 6 because you have to make 3 as whole number. So for more example, we have 750,100. To write the scientific notation is 7.501 times 10 to the power of 5. So you have to write only the significant figures in scientific notation. For the next example, 0.002403, in this value, you only have 4 significant figures. So in writing scientific notation, you only have to consider 4 significant figures. So the Sn of this value is 2.403 times 10 to the power of negative 3. More values. So we have the fifth example, 3,040,300. This value has 5 significant figures. So the Sn should have 5 significant figures. So the Sn becomes 3.0403 times 10 to the power of 6. Again, you only have to have in Sn one whole number. And for the last example, the sixth, 478.01. In this value, you have 5 significant figures. So all numbers are significant. So your scientific notation should have all these numbers. And it becomes 4.7801 times 10 to the power of 2. Two more examples. So, for the value 0.015409, it has 5 significant figures. So the Sn becomes 1.5409 times 10 to the power of negative 2 with 5 significant figures. And the last number is 0.7030 with 4 significant figures. So the Sn becomes 7.030 times 10 to the power of negative 1 with 4 significant figures. Let's go to conversion. Again, you need to be familiar with the SI units. What is also important in the conversion, you write the desired unit in the numerator. For example, in question number 1, 480 seconds, 2 minutes. There are 60 seconds in 1 minute. For the conversion, you multiply 480 seconds times 1 minute over 60 seconds. You cancel second and you are left with minutes. So 480 divided by 60 is 8. So your answer is 8 minutes. For the next example, conversion of 3,500 millimeter to meter, and there are 1,000 millimeter in 1 meter. So you multiply 3,500 millimeter times 1 meter over 1,000 millimeter, you get 3.5 meters. In the next example, number 3, convert 2,500 centimeter to megameter. So, before you can arrive to the desired unit, you have to have at least 2 conversions. There are 100 centimeter in 1 meter, and there are 1 million meter in 1 megameter. So, you multiply first 2,500,000 centimeters times 1 meter over 100 cm times 1 megameter over 1 million meter to arrive to 0.0025 megameter or capital M. Or you can write this in scientific notation, which is much easier. 2,500,000 becomes 2.5 times 10 to the power of 5 cm multiplied by 1 m over 10 to the power of 2 cm times 1 megameter over 1 times 10 to the power of 6 meters. You cancel cm and meters, you arrive to 2.5 times 10 to the power of negative 3 megameter or capital M, small m. Now we go now to the fourth example, converting 25 kilograms to micrograms. Just like the third example, you need to have 2 conversions before you arrive to the desired unit. Okay, you have to remember that there are 1,000 grams in 1 kilogram and 1 million microgram in 1 gram. So, you multiply 25 kilogram times 1,000 gram over 1 kilogram times 1 million microgram over 1 gram. You cancel kilogram and you cancel gram, you arrive to 25 billion microgram. Or you can use scientific notation. 25 kilogram times 10 to the power of 3 gram over 1 kilogram times 10 to the power of 6 microgram over 1 gram, you will have 2.5 times 10 to the power of 10 microgram.